Yes, sir.
Okay, bachcho. Please message your friends if you know. Ayman, Dervin, Man, Muhammad Ali, Navya, Nishta, Suraya, Zoha, please, Samir, Shariar. Okay. Okay, bacha. We are continuing this chapter 6, EMI. What is EMI? Electromagnetic induction. Am I visible to you? Clear? Audio is clear? Video is clear? Everything is clear? Please tell me. Hello? Ayman, बोलना भाई. Audio video is clear.
Yes, sir.
Girls, audio video is clear?
Yes, sir.
Okay. So today we are going to continue the same topic, chapter 6 EMI. Almost by this class or by the end of this class, by the tomorrow, we will finish this chapter. Very small chapter only. Small chapter, wonderful concepts, beautiful concepts are there. And 1 mark question, of course, 2 mark question or 3 mark question numerical, and then we can expect 5 mark derivation also. Two derivations, important 5 mark derivations is there. Based on that numerical also is there. Everything we are going to see. Again, just for 5 minutes, I'll recall because you should not forget the concept. That's why I'm going to recall you. So in this chapter, first what mainly we focus means as related to the first chapter. First chapter we studied that repeatedly. I'm telling you the same thing, same thing. Why I'm telling you the same thing means it should register at least till in your board exam. Till your board exam, it should register permanently in your mind. So in the first chapter, what we studied electric flux. The first chapter we studied electric flux. So what is electric flux? You know that EA cos theta. Electric flux is EA cos theta or EDS cos theta. Now the same question, the same formula we are studying in magnetic flux. Here we study as magnetic flux. The symbol is phi b. The symbol is phi b. Magnetic flux. The formula is same only BA cos theta. BA cos theta. So here again, what I would like to stress you. So please remember very carefully. B means E means electric field. A means area. Cos theta. Cos theta. Angle between electric field and area vector. Angle between electric field and area vector. This word you should memorize strongly. You should memorize. Otherwise, the problem will come when you do the numerical. When you do the numerical, whatever the angle they give, 30 degree I kept the coil to the magnetic field, then immediately you will take 30 degree. 60-degree inclined, the area of the coil, it is inclined at angle 60 degree with the magnetic field. Then immediately you will substitute the 60 degree. No, you should not do like that. So that we are going to see here. So you should be very clear that this cos theta tells you where. This cos theta depicts the angle. Cos theta tells you the angle between these two. You should remember very carefully between magnetic field and the area vector. Between these two only this cos theta will come. Whatever they give, that you should not substitute. If you substitute, your 3 marks numerical will go away. So that now last class also I taught you. Again, we are going to do some more concept based on this. Again, I will do the revision. Okay, so remember very carefully. What is the it when you write that? Simply you should not vague reading. You should not give electric flux E a cos theta, magnetic flux B a cos theta. No, no, no. You should understand. B is magnetic field line is going in one direction. एरिया वेक्टर ये दोनों एरिया कौन सा एरिया कहां पे एरिया वेक्टर जा रहा है तो ये दोनों का बीच में मैग्नेटिक फील्ड है और एरिया वेक्टर इस दोनों का बीच में cos theta हो रहा है so when you understand this very clearly then you will be able to do the numerical very beautifully 3 mark question okay bachcho okay now second thing what we studied means in this chapter we studied that first thing is we studied that Faraday's law. So Faraday's law, what he said. So before the Einstein experiment, he discovered that current carrying conductor around the current carrying conductor magnetic field lines is there. So here what he did, yes, magnetic field line also. Suppose if the magnetic field line is moving north pole, south pole, it is moving, then induced current is produced. Induced current or induced EMF, whatever we say, it is produced. So whenever the magnetic field line is changing, magnetic field around the bar magnet is changing. B is changing. So induced current, induced flux is produced. From the flux, induced current is produced. From the current, induced EMF is produced. Current so voltage सब कुछ बन रहा है ना बच्चों? So that we have seen. Now today's class, what we are going to see, in this also EMF, I gave you some formulas we have seen. EMF is equals to d phi by dt. D phi by dt we have seen. It is Faraday's law, which opposes the cause. Lenz's law, what he taught, EMF is equals to minus d phi by dt we have seen. And then we have seen EMF is equals to EMF is equals to if n number of turns is given, n number of turns दे दिया, so n d phi by dt. You can put number of turns. This means you have to add the number of turns. If it is not given, means no need to worry. Just EMF is equals to minus d phi by dt alone. You can put. So all these things we have seen. And some questions they will give flux, changing flux, final to minus, initial flux. So phi 2 minus phi 1 also you cannot. So all these things. Now second chapter, electrostatic potential, electric potential, chapter 2. Do you remember that we have almost a single letter V? In a single letter V, almost you will be having 6 formulas. Suppose if I ask you what is V, immediately what is the potential? Can anyone tell me what is potential? 10 second formula. V is equal to, jaldi boliye. Don't waste the time. Just for 5 minutes only
W by
recalling.
Q.
V is equal to
W by Q.
W by Q. Very good. So V is equals to W by Q. So one formula you understand. So potential due to a point charge. Potential due to a point charge. If I ask you, what you will say? 1 by 4 pi epsilon naught P by R square. You will say potential due to point charge. Potential due to any general point. What you will say? 1 by 4 pi epsilon naught P cos theta. P cos theta by R square. You will say. And potential in case of electric field is given. What is the formula? Potential in case of electric field is given. What is the formula? Hello.
V
Potential in
is
case
equal
of
to ED.
ah, ah,
V is equal to ED.
very good, very good. Who is that boy? Name of the boy.
Rayan.
Very good. So V is equals to ED. Potential difference is like that. Potential due to axial point P by R square and potential due to equatorial point V equal to 0. Now if you see here, all are V only. V. Like that you can see potential due to any general point, potential, simple potential formula, this one, potential if electric field is given V equal to ED. So if you observe here, everything is V only is given. But different segment is a different places we use this. But only thing is what we get potential for electric potential. Define electric potential means this formula. Electric potential due to a point charge. Electric potential, sorry, P by R. P by not R square, P by R. Then electric potential due to point charge V equal to 1 by 4 pi epsilon naught P by R square due to axial point, due to equatorial point. Potential due to electric field is given means V equal to ED, Vela equal to executive director. So like this, you remember what we are going to see here. Here so many V we have seen like this. In this chapter, what you are going to learn means so many E you are going to learn. So first three formulas I gave, EMF equal to rate of change of flux. First formula, then motional EMF we are going to find out. Then we are going to determine the rotational EMF. So what happens? So that means if B is changing, we get one formula. Faraday's law says therefore B is changing means we get one formula. EMF is equals to d phi by dt. Now today's class, what I'm going to teach you, how the area, if area is changing, how the flux is produced. From the flux, how EMF is produced. That's what we are going to see today. Okay. So this is about the recalling. Again, we will do from the second chapter. Okay, that is area. Any doubt is there? Any doubt is there? Someone is asking some doubt. Yes, tell me. Hello, someone asked something. Boliye. Any doubt is there? No doubt? Shall I continue?
Yes, sir.
Okay. Now, bachon, one more thing regarding numerical, I would like to share with you one information. With that, I will start the question. Okay, directly I'll go to the question. Ek dekho, bachon, what they say, numerical ka question dekho bachon. Phi B is equals to BA cos theta. Suppose if they say electric field at the area, rectangular area of 20 centimeter, 60 centimeter. So area is given, area of the rectangular coil is given. So this area of the rectangular coil making an angle of inclination 30 degree. So this area is making an angle of inclination 30 degree with the magnetic field. Then find out the flux or find out the EMF they are asking. So area is making an angle of 30 degree the Boreana. So with the field, suppose if the magnetic field line is going like this, imagine that magnetic field line is going. This area, this coil, you have to make like this 30 degree, it makes an angle. So this rectangular coil, how you have to keep, this is the magnetic field line means, this is the rectangular coil means, this rectangular coil is having 20 centimeter, 60 centimeter, it is given. So this coil, rectangular coil, how you have to make with the inclination, you have to make like this, that 30 degree, like this. Understand? So area ka dekho framework. You are keeping the area like this. Like this you are keeping. So this area, this rectangular area, is making an angle 30 degree here. Now you tell me that we have to find out the flux. If you want to find out the flux. So flux का formula क्या था बच्चों? BA cos theta. See, these are all the numerical questions. You should understand very clearly. You should understand. So BA cos theta. B is what? Magnetic field. Magnetic field some 10 to the power 5 Tesla they have given. Area to area 60 centimeter square. So what you will do? 20 into 60 centimeter square दिया तो क्या करेंगे बच्चों हमें 10 power minus 2 का whole square डालेंगे. So 10 to the power minus 4. Because I taught you already centimeter to meter convert करने के लिए use 10 power minus 2. तो square centimeter square बोलने से 10 power minus 4 डाल रहे. This and all you know already. तो मैग्नेटिक फील्ड का डाल दिया, टेस्ला दे दिया, कुछ दे दिया, एरिया वेक्टर भी डाल दिए. नाउ cos theta is very important. Can anyone tell me what is the cos theta here? Can anyone tell me? Degree will put. This is what generally you do the mistakes. Tell me. Can anyone?
Angle between area vector and magnetic field.
So what is that? Fantastic. What is that? What
Sir,
is that?
60 degree.
Very good. Who is that? Who is that?
I1.
देखो, so this is the area. तो इसका एरिया का वेक्टर कौन सा होता है? ये होता है. Normal drawn to the surface is called area vector. This for this area, this is the normal. Normal drawn to the surface is called area vector. तो ये एरिया का वेक्टर कहाँ बनेगा बच्चों? यहाँ पे बनेगा. यहाँ पे बनेगा. तो ये परपेंडिकुलर हो गया. So this is the area vector n cap. So this is perpendicular. This is area vector. So now area vector to the magnetic field. This angle only I want. I should not take 30 degree. ये angle मेरे को चाहिए. तो ये 90 degree हो गया. 90 minus 30 is 60 degree. So you will substitute here cos 60 degree. Otherwise, we will be losing unnecessarily 3 mark by substituting directly there. So these are all the concepts you should remember very carefully. Always remember that phi B is called magnetic flux. Magnetic flux means either B should change, flux produces, or A should change, flux produces, or cos theta should change. Cos theta should change. So flux will produce. Any one should change, then only the flux will produce. So these are all the things we have seen for the past 2-3 classes. Now we are going to see तो B का हो गया काम हो गया. अभी देखो एरिया चेंज होने से कैसा फ्लक्स प्रोड्यूस हो रहा है. That's what today class topic. Okay. Now I hope that you understand that to do the numerical concept also you understand here. Now take down the topic motional EMF because area is changing ना तो उसका टॉपिक होता है motional EMF. New formula you are going to learn. Very simple, very easy to understand, bachcho. So please take down the topic. Motional EMF. हो गया छाप लिए. Over.
Sir.
Hello, everyone. Please tell me.
No, sir,
Listen,
not
sir.
over.
Okay. Uh-oh. May I start giving the lecture? Okay. Now, bachon, listen here very carefully. So very carefully गौर कीजिए. What is given here in the diagram? We'll understand very clearly. A rail is given. Rail means some sort of rod. This is called rail. We say RAIL. Some sort of blue color rod is given there, and then in that rod, a flexibly moving one more rod is given. PQ is another rod is given. Okay. So PQ is moving. PQ movement का direction भी दिया है. This PQ rod, how it is moving means in this direction it moves. See the V velocity. The rod is moving inside. In this direction it is moving. Now length of this rectangular coil is given as L, or breadth of the rectangular coil is given as X. Up to this you understand? I hope so. देखो, L is length of the coil, X is the breadth of the coil. That PQRS is a rail, rectangular rail, and then PQ is a conductor which is flexibly moving in this direction or in this direction, any forward or backward direction it can move. Can you tell me if I put if I put cross, what is the meaning of cross? What is the meaning of cross?
Magnetic field lines going inside the board.
Very good. Who is that?
Suraya.
Suraya, lovely, mashallah. Magnetic field lines are going inside. Okay. Now, you know that palm rule, or you know the left hand rule, Fleming's left hand rule, whatever be the rule you take. Here, two things is given, third thing you have to say. See, two things is given. Magnetic field direction is given. Rod movement direction also is given. Can you tell me? So, velocity is given. That means velocity, movement of the conductor is given. V, movement of the conductor is given. Magnetic field is given. Can anyone tell me in which direction current is flowing in the rail? A rail पे current कौन सा direction में जाएगा? Clockwise direction में जाएगा या anti clockwise direction में जाएगा? जल्दी बोलिए. जल्दी
Sir,
बोलिए.
clockwise.
Clockwise. How you say clockwise?
Sir, by using right hand rule.
Right hand rule. Right hand rule. Palm rule बोलता है ना? Palm rule.
No, sir.
Then what?
Normal right hand rule.
Thumb rule.
Yes, sir.
हाँ. तो thumb rule use करते कैसा बोलेगा? बोलिए. What is this?
Sir,
What is this? हाँ.
sir, thumb is magnetic field.
But only two
So,
things only is there. Na? Thumb is the magnetic field, and this is the current
yes.
direction. But here we have to set three things, na? Because movement of the conductor भी बोला ना मैंने. Three
Sir,
things
we
भी
can
लिखे ना.
use Fleming's left hand rule as well.
Okay, Fleming's left hand use करके बोलिए. Current कौन सा मेरे को चाहिए? In this rail, whether it is clockwise, this is called anti-clockwise direction, or this is called clockwise direction. कौन सा direction में current जाएगा? बोलिए. कौन सा direction? Just think by using applying this rule, palm rule or Fleming's left hand rule, any rule you use. But which I want the current is going in this direction or current will go in this direction. Tell me.
So, clockwise.
This is called clockwise direction, and this is called anti-clockwise direction. The boy said clockwise direction. You will see that. Okay, whether he said correct or wrong. Now see that I'm taking the palm. This is my palm. Palm rule bolte. So this tells you the magnetic field direction, and this tells you the current direction. This palm gives you the force of a conductor. राइट हैंड पाम रोल इसको बोलते हैं पाम रोल में देखो ये मैग्नेटिक फील्ड डायरेक्शन 4 fingers मैग्नेटिक फील्ड डायरेक्शन and this gives you the movement of the conductor or velocity or something, and this gives you the force. We will see this. Okay, now listen here very carefully. Magnetic field lines are going inside, so I have to keep the 4 fingers towards the board, inside the board, so I kept like this. Now I'm showing the palm towards me. Why means movement of the conductor towards me. The conductor, PQ conductor is moving towards me. So I'm keeping like this. Now you see the very carefully my hand. The 4 fingers are inside the board, and movement of the conductor is towards me, this pen. Now if you see the thumb shows upward direction. Therefore, current flow in this direction, anti-clockwise direction. That means from P to Q in this conductor, current will flow like this, like this, like this. So normal current will flow in anti-clockwise direction. Induced current. So induced current, we are talking about the induced current to oppose the cause. So induced current will flow in which direction? Jल्दी बोलिए. Induced current will flow in which direction?
clockwise.
So इसका opposite में बोलना है. So induced current will flow in this direction. Very good, children. So please copy. If you know this, then theory writing and derivation is two-line derivation. So please take down the little bit theory. Consider a conductor PQ. Consider a conductor PQ of length L. Consider a conductor PQ of length L free to move in a U-shaped rail. U-shaped rail. U-shaped rail. हो गया? हो गया?
जी सर.
By using right hand palm rule or Fleming's left hand rule, by using right hand palm rule or Fleming's Fleming's left hand rule, we understand. Next paragraph, we understand the induced current produces in anti-clockwise direction. Anti-clockwise
Sir, can you
direction.
please repeat?
Huh?
We understand के बाद से can you please repeat?
You can understand, here I am writing now, the induced current produces in anti-clockwise direction in the coil. हो गया? हो गया? We know flux produced is, what is the magnetic flux formula? What is the magnetic flux formula? Hello, what is the magnetic flux formula?
ये cos theta sir.
BA cos theta.
Yeah, BA. हो गया?
Okay.
हो गया?
हो गया sir.
Now, next step. What is area? Area का formula substitute कर लो. We know pi b is equal to b into area क्या है भाई? L into x. L into x. Again, also we know induced EMF. Induced EMF का formula क्या दिया था? Lenz law. Induced EMF. What is the Lenz law formula? Induced EMF. What is the
Minus
formula?
d5 by dt.
Very good. Minus d5 dt. Very good. So substitute कर लो बच्चों. EMF therefore EMF equal to minus d by dt of phi का फार्मूला इसको सब्स्टिट्यूट कर लो. phi का फार्मूला इधर डाल दीजिए. BLX. magnetic field and length of the conductor is not going to change. Magnetic field and length is not going to change. Only the breadth is going to change. Why the breadth is going to change? Because the conductor is moving. So the x will change. यहाँ पे तीनों letters है B, L, X. B will not change. Magnetic field is not changing. L is not changing. But X is changing. The area because of the movement of the conductor. Therefore, EMF is equals to minus, इसको बाहर निकालो, B को L को बाहर निकाल दो, minus dx by dt. If you girls, if you say, I'll be very happy. What is the 9th standard formula? dx by dt. 9th standard में क्या पढ़े? dx by dt का formula क्या है? Girls. Any one girl. dx by dt का formula क्या है? 9th standard.
V
11th standard. What is dx by dt? जल्दी बोलिए बच्चों.
V
Huh?
velocity
Velocity, who is that?
Aisha.
Very good. MashaAllah. So substitute EMF is equals to minus BLV. EMF is equal to minus BLV. हो गया? Here, the negative sign indicate the decreasing direction of x. So this is your one more formula we understand. EMF is equals to minus BLV for numerical purpose. Another formula. तो कितने फार्मूला देखो, EMF is equals to d5 by dt पढ़े थे, अभी देखो न्यू फार्मूला एक लर्न कर लिए, मोशनल EMF का फार्मूला EMF is equals to minus BLV velocity. तो याद रखना, ये भी मेमोरी करना फॉर न्यूमेरिकल. After finishing, please tell me, we'll go to the next topic. हो गया? Amen. Amen.
Yes, sir.
पार्टिसिपेंट लिस्ट चाहिए बेटा,
Sir, उठा लिया सर.
भेज दिए?
Yes, sir. आपको भेज रहा हूँ.
ओके ओके, थैंक यू. बच्चों हो गया? साइड ऑफ द बोर्ड.
Yes, sir.
Darwin,
Yes, sir.
finished?
Yes, sir.
Very good. Let me check that. How many is there? अरीब हो गया बेटा? अरीब, Ayman,
Yes, sir.
Darwin, then Faliha,
Yes, sir.
Ali, Navya. Oh, welcome Nishika. Nishika, this is the first class I think.
Hello,
for
sir.
you.
Good evening.
What happened, Nishika? What is this? What happened? Where are you?
Nothing, sir. Was roaming here and there.
Oh my God, enjoying. Okay, vacation.
How are you,
Rayyan.
sir?
Yeah, fine, beta. Rhythm, how are you? Rihab.
I'm fine, sir.
Rhythm, are you attending regularly?
Yes, sir.
Okay. Okay, beta, okay. Good. So, देखो बच्चों, this chapter itself, we have seen that this is the third formula, I think so. EMF is equals to, so I said step by step, we have to remember EMF is equals to d5 by dt first formula. EMF is equals to d5 by dt Faraday's law, Lenz's law, minus that opposing the cause induced EMF pucha to minus EMF by minus d5 by dt. And then we are suppose if n number of times means n d5 by dt. Yeah, motional EMF का बारे में पूछा तो motional EMF. Remember the topic. Motional, determine the motional EMF. Motional EMF का formula है EMF is equals to BL. And then we are going to see today itself rotational EMF. Before going to that, we are going to see same topic, motional EMF, second method or method. Okay, different method. So same diagram, same topic. Please take down motional EMF again. Again, take down the same topic only. Motional EMF method 2. So first method you write in bracket you put motional EMF Faraday's law. Faraday So first method is, you please write down, I forgot to tell you, motional EMF topic in bracket you put Faraday's law, first method. Abhi jo kare na? So EMF equal to minus BLV. So in that you write down motional EMF in bracket you put Faraday's law by using Faraday law. If they ask means the procedure, whatever I taught you just now, you have to do that. Okay. Now second method. Second method, same motional EMF. Second method, motional EMF by using Lorentz force. Can anyone tell me define Lorentz force? What I taught you, what is Lorentz force? Can anyone remember the formula? Lorentz force definition. Define Lorentz force. Ready, boliye. Oh my
The
God.
direction of the induced current opposes the Gauss.
No. Lorentz force definition. What is Lorentz force?
Sir,
Oh,
both electric and magnetic force together.
who is that? Who is that?
Iman.
Ayman, good. Combined effect of electric force and magnetic force is called Lorentz force. I gave you a simple definition. Combine the effect of electric force. Combine the effect of electric force. तो इलेक्ट्रिक फोर्स को कैसा में लिखते हैं बच्चों? इलेक्ट्रिक फोर्स को एफ ई बोल के लिखते हैं, रिवर्स में पढ़ना है. जब पढ़ने के टाइम में कैसा पढ़ते हैं? रिवर्स में पढ़ते हैं. इलेक्ट्रिक फोर्स, combine the effect of electric force and magnetic force, BF. मैग्नेटिक का सिंबल आपको बी यूज करते हैं, फोर्स का सिंबल एफ यूज करते हैं. ओके, नाउ कैन एनीवन टेल मी व्हाट इज इलेक्ट्रिक फोर्स का फार्मूला? हम पढ़े थे चैप्टर 1. व्हाट इज इलेक्ट्रिक फोर्स फार्मूला? विदाउट फार्मूला वी
QE.
कैन सी रिपीटेडली. यू शुड डू द रिपीटेड फार्मूला, रिवाइज करते रहना भाई, नहीं तो सब्जेक्ट समझ में नहीं आएगा. See, there is a link between, I told you na, unless you study first 4 chapters, you will not understand this chapter. And one more important, very important information I'm going to tell you. अरे बच्चों, ये तो बहुत आसान टॉपिक है. Chapter 6 EMI is very easy. But next topic is called Chapter 7 alternating current. When you don't know these formulas means, then it is highly difficult, where we are going to see full of mathematical concepts there. Differentiation, integration both use होता है बच्चों. Full of alternating current, where we are using at our house है ना. तो अल्टरनेटिंग करंट का पूरा चैप्टर क्या होता है बच्चों? डिफरेंशियल इंटीग्रेशन. वी आर यूजिंग दैट. So please, if you miss even a single class, then you find very difficult with that topic. Graphical method, everything is there. तो बच्चों आपने 7th chapter is highly difficult because of the differentiation integration. Usually non-math students they find very difficult. तो इनके लिए मेरा रिक्वेस्ट है, please never miss the class of chapter 7 alternating current. Okay. Now can anyone tell me what is electric force? first chapter का फार्मूला जल्दी बोलिए बच्चों. जल्दी बोलिए. QE. Fantastic. What is the magnetic force का formula?
QEB.
QVB sin theta.
Huh?
QVB sin theta.
QVB, very good. QVB, mashallah. Lovely girl. Okay, good. So this thing we are going to use here. So take them the same diagram, please. Good children, very good. तो आपको पता है ना बच्चों, तो इफ आई पुट क्रॉस, व्हाट इज द मीनिंग ऑफ क्रॉस? मैग्नेटिक फील्ड लाइन आर गोइंग इनसाइड द बोर्ड. तो यहाँ पे लिख लीजिए बी वेक्टर. बी वेक्टर मींस मैग्नेटिक फील्ड लाइंस आर गोइंग इनसाइड द बोर्ड. सेम प्रीवियस टॉपिक जो किया थे वही होता है, बट बाय यूजिंग लॉरेंस फोर्स. ओके, तो मैग्नेटिक फील्ड लाइंस आर गोइंग इनसाइड. तो व्हाट इज द कंडक्टर मूविंग डायरेक्शन? कंडक्टर तो ये डायरेक्शन में मूव हो रहा है, कंडक्टर ये डायरेक्शन में मूव हो रहा है. तो पाम रूल यूज करो बच्चों. सो मैग्नेटिक फील्ड लाइन, तो देखो पाम मेरे को देख रहा है. सी दिस इज कॉल्ड द पाम, दिस पोर्शन इज कॉल्ड द पाम. दिस पाम इज सीइंग मी. सी ऐसा रखा तो मैग्नेटिक फील्ड का डायरेक्शन में 4 फिंगर रख दिया मैंने, तो पाम इज सीइंग मी, तो फोर्स हो गया, मैग्नेटिक फील्ड हो गया. नाउ सी द करंट डायरेक्शन. Current direction going upward in the conductor. That means it goes in this direction. Anti-clockwise direction is the normal current. But we talk about the induced current, which opposes the cause. So it is opposite to the direction. So it goes like this, induced current. Same diagram. No, diagram is not changing. Same diagram. Okay. Only theory is changing. हो गया? LX, LX. Length is L, breadth is X. Consider a conductor PQ. Consider a conductor PQ is moving freely in a U-shaped rail. In a U-shaped rail. Imagine magnetic field lines are going inside the paper. Imagine magnetic field lines are going inside. Imagine B vector, magnetic field lines are going inside. हो गया? Imagine magnetic field lines are going inside, and the conductor PQ is moving in negative X direction. The conductor PQ is moving in negative X direction. The conductor PQ is moving in negative X direction. Therefore, induced current produces in clockwise direction in the rail. Induced current produces in clockwise direction in the rail. खलास हो गया? theory हो गया?
हो गया सर.
So just now one girl told very beautifully electric force and magnetic force का फार्मूला, तो वो दोनों ही मैं लिखा हूँ, क्योंकि यहाँ पे देखो बच्चों, यहाँ पे दोनों फील्ड भी वर्क कर रहा है. Since the current is moving, we can say electric force. Since the magnetism we are using here, magnetic field lines are going, so magnetic force. दोनों force भी यहाँ पे involve होने से, तो we are taking that, considering what is the electric force from first chapter formula we are taking, and what is the magnetic force formula also we are using, QVB. Okay, so please copy this. Allow me to rub the diagram alone, this part. Comparing one, because when Max says that when left hand sides are equal, obviously right hand side also equal. So comparing 1 and 2 equation, comparing 1 and 2 equation, QE is equal to QVB. तो आपको क्या मिलेगा? E is equal to VB. So this is over. हो गया? Over. Hello, hello, hello.
Yes, sir.
ऐशा हो गया? अली?
Done, sir.
निश्ता? सुरैया? जोहा? हो गया?
Yes, sir.
Yes, sir.
फातिमा? Hello? Fatima is there? हो गया बच्चों? Shall I continue? Now listen here very carefully. Electric force is QE. You only said that from the first chapter. Again, from the fourth chapter, you only said that magnetic force is QEB. Okay, please listen very carefully. So, electric force, magnetic force. दोनों भी force रहने से we compare the both the equations. We get that E equal to VB. Now, my question to you is, well, suppose in the diagram, if you see the diagram, PQ, the rod is here, PQ. The potential difference developed, the potential, that means because of this electric field is there, because of this magnetic field is there, therefore potential difference is developed. Potential difference means V, symbol is V. The potential difference developed in the rod PQ. तो उसका फार्मूला, पोटेंशियल डिफरेंस का फार्मूला क्या है, V का फार्मूला क्या है? Here what we use, potential difference का फार्मूला, what type of formula we have to use? Out of that 7 formula, can anyone tell me? Second chapter, V का 7 formulas are there. V equal to W by Q, V equal to 1 by 4 pi Q, P का so many formulas I taught you just now in the beginning of the class. तो उसमें कौन सा फार्मूला यहाँ पे यूज करेंगे? Potential difference developed in the rod PQ. जल्दी बोलिए.
Yes, sir.
Huh? Louder please. Which formula you will use? अरे बच्चों तो आपका ऑडियो नहीं मिल रहा, प्लीज. I'm not getting your audio.
So V is equal to ED.
V equal to ED, very good. Why we are using this V equal to ED here? Very carefully listen here. So V equal to ED, Velamal is equal to, I told you the short trick also to remember this. Velamal school में जो काम किया था वहाँ पे principal होता है executive director. So Velamal is the executive. Why we are using this formula? Potential difference developed equal to, because here electric field is there. Electric field is developed. So we are using this ED. तो यहाँ पे देखो फार्मूला में सब्स्टिट्यूट करेंगे बच्चों. Therefore V is equal to E. What is E? You get already here. तो V का फार्मूला आपको मिल गया. तो VB, V, यहाँ this V is different. अरे बच्चों don't get confused please. This V and this V is different. This is potential different. This is velocity. That's why I wrote here. Here V is velocity. So please never get confused. This big V डाल रहा हूँ यहाँ पे, मैंने small V डाल रहा हूँ, आपका confuse नहीं होना बोल के. तो V equal to Velamal equal to E का फार्मूला V भी डाल दिया मैंने, और distance of the conductor is L. So it is there in the diagram. So L डाल रहा हूँ मैंने. So potential difference V, the other word, the other symbol we use, can anyone tell me what is the other symbol for V? V or similar symbol. What is the other symbol? Other symbol कौन सा use कर रहे हैं मैं? जल्दी बोलिए.
EMF.
Very good one. So instead of V you can write R डाल के लिख सकते हैं. Just you put instead of R EMF. Instead of V you can write EMF. EMF is equals to BLV. BLV. So see that same formula we get by using the Lorentz force method also. By using Lorentz method, also we get the same formula. EMF is equals to BL. खलास बच्चों, हो गया? Now, continuation. Okay. What is Ohm's law formula? What is Ohm's law formula?
Yes, sir. E is equal to IR.
What is Ohm's law formula? Anyone?
V is equal to IR.
Oh, lovely. वाह रे वाह. कौन है भाई वो? इतना sound very good. हाँ?
Iman.
I1, lovely Iman. V equal to IR. So Ohm's law, V is equals to IR. So if I ask you V equal to IR, what is current from this formula? From this formula, what is current?
V by R.
Very good. So substitute current produced. Second, next step is current produced I is equal to, instead of V by R, you can write E by R. E by R. So E का formula क्या है? BLV. So BLV by R. Current produced. So this is one more. All the formulas are used for numerical purpose. So current produced I is equals to BLV by R. Okay. Then force developed in the conductor. Force developed in the conductor. Yes. Can anyone tell me? Again, fourth chapter. See how many formulas are involving. Since you missed the fourth chapter कितना important है? तो सारे formulas उसमें से ले रहे हैं हमें. Can anyone tell me what is the force developed in a conductor in a magnetic field? In a magnetic field, we have seen this topic. Force on a current carrying conductor. What is the formula? Force on a current
F is
carrying.
equal to BIL
उसके बाद one
sin
more.
theta.
Who is that?
Sin theta.
Who is that?
Nishika.
Nishika, lovely Nishika. Wow. Very good, very good. F is equal to Bill sin theta. We know already. So force developed in the conductor is F is equal to Bill sin theta. Mashallah. Bill sin theta. Here sin 90 is 1. So remove that sin 90. Sin theta goes. F is equal to, therefore, F is equal to B. I. B डाल लीजिए. I का फॉर्मूला ये सबसे कर लो. B L V by R और यहाँ पे L है. This is 90 degree. So remove this. Sin 90 is 1. So you can remove that. Okay. Therefore, F का formula मिला. Shall I rub this part? Hello.
Yes,
बच्चों,
sir, you
कोई-
can. Yes, sir.
Okay.
Yes, sir.
तो देखो बेटा, one more formula. We are getting a new formula. Force का एक नया formula मिल रहा है in motional EMF. All this formula, if you remember, then you can do very beautifully 3-mark numerical. Otherwise, numerical will become very tough. So multiply करके लिखो. Therefore, F is equals to B into B square, L into L square, B square, L square, V by R. B square, L square, V by R. So this is the force formula in motional EMF. हो गया? Then two more formulas. Power delivered, power developed, and power dissipated. Power developed, power dissipated. दो चीज होता है. Power developed because of the movement. What is the power induced? Power developed in the conductor. और क्या होता है? Because of the heat produced. What is the power dissipated? तो दोनों फार्मूला हमें करने जाते हैं बच्चों. This also you know from 10th standard. So the next our continuation only. So power delivered. Power delivered. P is equals to 11th standard formula. बच्चों, I taught you P का एक 5 formula मैंने बोला था. Can anyone tell me all the 5 formulas? I'll be very happy. फटाफट बोलना है. P का 5 formulas I taught you. Please remember this formulas बोल के. Just for recalling purpose. जल्दी बोलिए.
P equals W by T,
Okay.
I square R,
Okay.
V square by R,
Okay.
VI,
Okay.
and FV.
Who is that?
Faliha.
Faliha, mashallah, Allah bless you, dear. Very good, dear. So this many formulas I taught you. Power का formula 5 formula बोल दी है बच्ची. P W by 2, W by T, I square R, V square by R, VI, FP. यहाँ पे देखो बच्चों, power delivered. We are taking the 11th standard formula FV. So power delivered, power dissipated का formula इसमें ही मिलता है ना? So therefore power delivered is equals to F क्या है बच्चों? इसको सब्स्टिट्यूट कर दो. V square L square V by R. और यहाँ पे क्या है? Velocity. So therefore P का एक new formula आपको मिल रहा है. B square L square V square by R. So this is the new formula for P. New formula for F. So please note down all these things. हो गया? Continuation only. Don't stop or don't put line and all. Please continuation only. These are all the steps to do the numerical. You should remember the formula. You should memorize the formula. Otherwise numerical नहीं आएगा. Motional EMF में numerical नहीं आएगा. If you don't remember the formula, बच्चों again and again I'm requesting, please once 5 minutes, please recall all the previous chapters. 5 chapters I finished. All the 5 chapters formulas, please recall. The last one, power dissipated. Power dissipated. E equal to I square. Already I did the I formula, तो ऐसे copy कर लेंगे I का formula. BLV by R. Second step में किस there? I का formula BLV by R square. That's all बच्चों, this question.
Done, sir.
Very good. Girls,
Sir, so power delivered or dissipated में the formula is same only.
no. Power dissipated is different. That is end formula you are getting. But what is the meaning? Meaning क्या होता है बोलो? Formula is same only, but what is the meaning you get? Meaning आपको समझ में आ रहा है?
नहीं sir.
Meaning क्या समझ में आ रहा है? See, power produced बोलते ना. Rate of doing work is called power, है ना बेटा?
जी.
Rate of doing work. You said ना 5 formula बोले थे ना, आपने याद आया?
जी जी.
So power produced बोले तो rate of doing work P equal to W by T है ना?
Yes sir.
So what is the power developed? What is the power produced? What is the power in watts? Different type of situations में power produced एक होता है. ये power, but formula may be same. End formula is maybe B square L square V square by R. End formula is different. That is same one only. But what is the meaning you have to understand? Power developed कब होता है? Power produced कब होता है? Power dissipated. ये power dissipated कब होएगा? What is the meaning of dissipation? Hello? What is the meaning of dissipation? Can anyone tell me?
Distributed.
Distribute, when the more heat is produced means power dissipation होता है ना, power loss होता है ना.
जी.
समझ में आ रहा है? When any
जी.
coil more heat is produced means power loss होता है ना, तो उसको बोलते हैं हमें power dissipation. समझ में आ रहा है?
जी जी.
So वो टाइम पे अपने I square R V square by R भी यूज कर सकते हैं. Shall I give you one numerical?
No.
जल्दी करो. Hello? Boys, girls, over. Side of the board. Hello? Side of the board.
Yes sir.
Shariar Salsabil is there?
Yes, sir.
Yes. अभी एक क्वेश्चन आपके लिए. Now there is a diagram is given, बच्चों. One graph is given. देखो बेटा, numerical. A graph is given like this. Here they say magnetic field. Here they give the time. Y-axis they have taken magnetic field. X-axis they have taken time. Just we should know the numerical, how to do the numerical. Okay, answer and all I'll give you nothing to worry because it takes longer time. Just to understand the numerical we'll do. कैसा कर सकते हैं इसको? Okay. तो ग्राफ कैसा दिया है बच्चों? Y-axis में मैग्नेटिक फील्ड दे दिया, X-axis में टाइम दे दिया. तो ये ग्राफ दिया है बच्चों. Just it goes like this. Okay. So 1, 2, like that. Now they have given the time in seconds 0, 2, 4, 6. 0, 2, 4, 6. So time in seconds they have given. Time in seconds. और मैग्नेटिक फील्ड दिया है 1 टेस्ला 2 टेस्ला. This is 1 Tesla. This given. This is 1 Tesla. All these things for your knowledge only. So here they have given 1 Tesla. Here they have given 2 Tesla. A circular coil. Circular coil. 12 centimeter. 12 centimeter radius. Circular coil 12 centimeter radius. 8.5 ohm resistance. 8.5 ohm resistance. Changes with the time. Changes with the time as shown in the graph. Calculate the induced current. Calculate the induced current. A 3-mark board question. Just you think first and tell me, give me your ideas how to solve this numerical. What is the formula you will use? Yes, I can. Yes, bachcho, any one boy. Just apply your. I want induced current. At least you tell me the first formula.
Sir, E by R.
Very good. Who is that?
Ali.
Ali, fantastic Ali. Ali, तू नहीं बोला रहेगा, आयशा बोले रहेगी, सही है? Monkey, सच बोल.
Sir, मैंने बोला सर.
Monkey, I can't believe you. सच बोल रहे. Allah is watching you. जल्दी बोल. अजान दे रहे हैं. सच बोल. तू बोला या आयशा बोली? जल्दी बोल.
Sir, मैं बोला सर.
तूने बोला?
हाँ सर.
Very good boy. Very good boy. माशाल्लाह, माशाल्लाह. मबरूक बेटा. तो induced current. देखो बच्चों. We know induced current I equal to E by R. I equal to E by R. What is E? EMF का फॉर्मूला क्या होता है? I'm asking you only. Hello. What is EMF? Oh my God. अरे बच्चों.
Sir. Sir, d5 by dt.
हाँ, very good बेटा. So EMF is equals to minus d5 by dt. Very good. What is phi?
DA cos theta.
dA cos theta.
Very good. Cos theta छोड़ दो. d by dt of B. अच्छी बात है. Area of the coil current. First you say area of the coil. Area of the coil यहाँ पे क्या use करेगा? Circular coil means what is the area?
2 pi r.
Very good. हाँ? Pi r.
Pi r square sir.
Oh my
Pi-
God. What
Pi
Ayman?
r square sir.
कहाँ रहे Ayman? Where are you? Nonsense. Saying wrong formula. area of the coil pi r square. Ayman, hello Ayman.
Yes, sir.
pi r square का वैल्यू बोल, पाई का वैल्यू क्या होता है 3.14. r स्क्वायर का वैल्यू बोलिए मेरे को, सब्स्टिट्यूट करके बोलिए.
Sir, 12 into 10 to the power minus 2 whole square.
वेरी गुड बॉय. 12 into 10 to the power, तो उसको हमें कैसे कर
Minus
सकते
2.
हैं? -2. ओके
0.12.
ओके 0.12 स्क्वायर. तो इसका आई गिव यू द आंसर बिकॉज नो नीड टू, इट विल टेक टाइम. आंसर पूरा सब मैं दे देता हूं, बट I want you to understand the numerical. So this one I'll give you the answer. Okay, nothing to worry. Don't need to waste our time. इसका आंसर मैंने दे दूंगा, but you should tell me how to do the numerical. वो अंडरस्टैंड करना है. तो इसका आंसर मैंने दे देता हूँ. एरिया का आंसर क्या दिया है इसमें? दिया है बच्चों 4.5 into 10 power minus 2. 4.5 into 10 power minus 2. तो इसको एरिया को सेपरेटली you keep this answer. So you got the area. dA is there. d5 by dt. So first step is what is induced current. So induced current means, you know, induced current का फार्मूला पहले बोल दिया आपने. Very good, congratulations. Some student they said I equal to E by R. So E means E you can say, or V also you can say, potential difference from Ohm's law. I equal to E by R. So what is E? E आपको again you know EMF. What is EMF? Rate of change of flux. What is EMF? Rate of change of flux. So EMF is equals to minus d5 by dt. So EMF is equals to rate means time, rate of change of flux, phi. Again you know EMF is equals to minus d by dt of phi का फार्मूला आपको तो पता है. Phi means what? Flux. Flux means what? BA cos theta. Cos 0 is 1. So BA ले लिए. Okay. So in this also you see that area first we are calculating, we are keeping ready because of the circular coil. We are using the mathematics formula pi r square. तो pi का वैल्यू डाल लिया आपने. r स्क्वायर 12 सेंटीमीटर को क्या करें, मीटर में कन्वर्ट कर लिए और उसका स्क्वायर डाल लीजिए. तो 4.5 10 पावर माइनस 2 मिल गया, आंसर मिल गया. तो ये एरिया मिल गया आपको. ओके. नाउ फ्रॉम द ग्राफ you have to calculate flux, sorry, magnetic field you have to calculate. B आपको calculate करना चाहिए with respect to time. How we will do that? Yes, now you tell me. कैसा करेंगे? एरिया मिल गया भाई. Now see the formula. In the format is there. EMF is equals to एरिया को बाहर निकाल दो. Minus dB by dt is there. dB होना चाहिए, dt होना चाहिए. कैसा करेंगे? From the graph. जल्दी बोलिए. Up to this first you copy, please copy up to this. After copying, tell me. Please tell me, but up to this you copied. First you tell me, copied or not? Up to this you copied? Hello, hello, hello. हो गया, कॉपिंग हो गया. यहाँ पे मीटर स्क्वायर का लीजिए. तो एरिया इक्वल टू 4.5 10 पावर माइनस 2 मीटर. कॉपीड. ऑल ऑफ यू कॉपीड और नॉट? जल्दी बोलिए.
Yes, sir.
ओके. Who is not involving? Timothy? Hello, Timothy.
Yes, sir. Yeah.
Copied बेटा.
Yeah, I took screenshots, sir.
ओके ओके. समीर, रे कश्मीरी, हो गया?
जी सर.
Very good. Ray, don't forget to bring apple from Kashmir.
सर सैफरॉन भी लाऊंगा, कोई बात नहीं.
Oh, रैयान, रैयान क्या कर रहा है भाई? रैयान, हेलो.
यस सर.
कर रहा है, कॉपी कर रहा है.
लिख लिया सर. यस सर.
डरविन, अरे हेलो
Yes, sir.
डरविन. ओके गुड. नो बच्चों देखिए बच्चों, फॉर्मूला मैंने यू सी दैट वी वांट दैट इंड्यूस्ड करंट मेरे को चाहिए, बट आई वांट दैट ई मेरे को पहला चाहिए. Resistance is given, 8.5 ohms resistance is given. So first thing is I should calculate EMF. तो EMF में calculate किया तो then I can substitute that I का वैल्यू जाके E का वैल्यू डालूंगा और R का वैल्यू भी डाल सकता हूँ. Then I can do the numerical. So first thing is I'll make it step by step. I'll make it ready everything. Okay. Now next step what we have to do. देखो ये तो मिल गया. dB by dt is there in the formula. So how to calculate that dB by dt from the graph? Any idea from any one student? Career?
B2
Volume?
minus B1 by
Very good,
T2
very good,
minus
very,
T1.
very good boy, very good boy. So therefore EMF is equals to, देखो बच्चों, ये को बाहर निकाल दो, you know already ये को तो मिल गया, तो ये को बाहर निकाल दो माइनस ये, और यहाँ पे लिखो dB by dt, dB by dt. So difference in magnetic field, difference in time with respect to graph. Difference in magnetic field and difference in time with respect to graph. That means this is the first part, this is the second part, this is the third part. Magnetic field is increasing 0 to 1 Tesla, and then the magnetic field is constant, and then the magnetic field is decreasing. Understand? तो ये याद रखना, magnetic field कहाँ से कहाँ तक है? 0 to 1 maximum है. 0 to 1 is the maximum is there. और टाइम देखो बच्चों, फर्स्ट 2 सेकंड्स में 0 to 1 है, और देखो बच्चों 2 to 4 सेकंड्स में मैग्नेटिक फील्ड कांस्टेंट है बेटा, नॉट ऑल इंक्रीजिंग नॉट ऑल डिक्रीजिंग. और देखो बेटा 4 to 6 सेकंड, 6 सेकंड में जब क्या होता है, मैग्नेटिक फील्ड इज ऑन गोइंग ऑन डिक्रीजिंग. So what we have to write this formula थोड़ा change करेंगे. देखो EMF is equals to minus A. All non-max students please listen very carefully. Slowly you understand. Maximum dB means difference in magnetic field. Maximum magnetic field minus less magnetic field. So B2 ये point रख ले तो B2 रख ले ये B1. So maximum minus initial or final minus initial. So in this part of the graph में ये maximum point होता है, ये minimum point होता है, or you can say this is the final point, this is the initial point. Any way in English you can use. So dB का जगह मैंने लिख रहा हूँ B2 second point, B final point to B initial point, B first point. In the same way टाइम का भी देखो, टाइम का ये सेकंड पॉइंट, ये टाइम का इनिशियल पॉइंट. सो टाइम का फाइनल पॉइंट माइनस टाइम का इनिशियल पॉइंट. So now this formula has been changed according to the graph like this. Now you can do the numerical variation. So to make you to understand this only, I am doing all this setup. तो नोट कर लीजिए. हो गया बच्चों? सुरैया हो गया?
जी सर,
Now
वो
Suraya
लास्ट
only, now Suraya only has to answer me. So ये according to this formula, according to these letters, whatever I have written here, you have to give me the answer. If you answer me, really I will be very happy. ये इसको देखो, घबराई नहीं करना, नहीं घबराई नहीं, घबराई नहीं करना. भाई घबराई नहीं करना है. फर्स्ट ट्राई टू अंडरस्टैंड. बहुत आसान आता है, बहुत आसान होता है. आई नो दैट योर डिफिकल्टी, आई नो दैट यू आर नॉन मैथ्स स्टूडेंट्स, आई नो एवरीथिंग आई नो, बट स्टिल हाउ इट इज इजी. कितना आसान है देखो, कितना आसान है देखो. अभी आप देखो. Okay, so all these things you rub it. Now slowly you will understand. The first thing is, first part of the graph में हमको आंसर मिलने वाला है. देखो EMF is equals to माइनस ए का वैल्यू तो मैंने दे चुका हूं, तो उसको कॉपी कर लेंगे. 4.5 into 10 power minus 2, 4.5 into 10 power minus 2 मीटर स्क्वायर. तो ये का वैल्यू तो डाल दिया मैंने. अभी देखो बेटा B2 magnetic field final point minus magnetic field initial point. So in this first part, what is the final point? 1 Tesla is the final. So B2 का 1 Tesla और B1 is 0, तो 1 minus 0. खलास. देखो कितना आसान है. देखो 1 minus 0 और टाइम, फाइनल टाइम माइनस इनिशियल टाइम. कहां से कहां तक गया भाई? यहां से यहां तक ग्राफ गया ना, तो फाइनल टाइम ये होता है 2 होता है, इनिशियल टाइम ये होता है, तो 2 माइनस. खलास, कितना आसान है. देखो सो 1 minus 0 व्हाट इज द आंसर? सही बोलिए. 1 minus 0 1, 2 minus 0 व्हाट इज द आंसर?
2.
So 1/2 हाफ होता है ना, तो 1/2 हाफ से है ना, इसको डिवाइड कर दो, you will get the answer. So this is the step. So what is the answer I'll give you? No need to waste your time. EMF is equals to minus 2.25 into 10 power minus 2. खलास, इसका डिवाइड बाय 2 डाल दिया तो minus 2.25 into 10 power minus 2. खलास, तो आपको EMF मिल गया. So they are asking induced current. So first part of the graph means this is the first part of the graph. ये ट्राइंगल होता है ना, ये फर्स्ट पार्ट होता है. तो इसमें देखो इंड्यूस करंट आपको चाहिए I इक्वल टू E/R. तो E का वैल्यू क्या मिला आपको? -2.25 into 10 power minus 2 मिला. रेसिस्टेंस न्यूमेरिकल में क्या दिया था भाई? कैन एनीवन हेल्प मी? हेलो.
8.5.
8.5 वेरी गुड 8.5 ohms. तो आप इसको मार पीट के देखें तो आपको आंसर मिल जाएगा. दैट आंसर आल्सो आई गिव यू व्हाट इज आंसर. You get that 2.7 milliampere. 2.7 milliampere is the okay. So first part I did. Now I want from you the second part. Only a substitution I want. If you know the substitution, that's what I want. Because many children they get confused in the substitution. अभी देखो second part, third part में कैसा substitute करके that substitute. First part you copy this and I wait for you and tell me boy or girl whoever it may be you can say that second part substitution, third part second part substitution पहला बोलिए. Second part of the graph. The way how I did, the same way you have to do. Arif also you can say second part. This is the first part is over. This is the second part of the graph. This is the third part of the graph. Okay. Just substitution only you can say. No need to give answer also. हो गया बच्चों?
Sir,
हाँ.
minus 4.5 into 10 raised to minus 2 minus 2
Okay बेटा.
bracket into 1 minus 1 by 4 minus 2.
Very good. Very good. Who is that? Very good. Who is that?
Me, sir.
Me means how I'll understand. क्या मैं देख रहा हूँ मैं. Name जल्दी बोलिए. हाँ?
Ali.
अली वेरी गुड अली. देखो तो यहाँ पे देखो ये फाइनल पॉइंट हुआ ये इनिशियल पॉइंट हुआ. सेकंड पार्ट ऑफ द ग्राफ में ये फाइनल पॉइंट बना. ये फाइनल पॉइंट हुआ. यहाँ पे लिख दिया था कंफ्यूजन. ये फाइनल पॉइंट ये इनिशियल पॉइंट हो गया. तो फाइनल पॉइंट इज दिस पॉइंट. इनिशियल पॉइंट इज दिस पॉइंट. तो मेरे को मैग्नेटिक फील्ड चाहिए. ओके बच्चों. ऑल ऑफ यू कॉपीड दिस. शैल आई रन दिस पार्ट. फर्स्ट पार्ट इज ओवर. यू पुट हियर रोमन लेटर 1. रोमन लेटर 1 मींस फर्स्ट पार्ट इज ओवर. हो गया. शैल आई रन द बोर्ड. हेलो गर्ल्स प्लीज टेल मी ना.
जी
अरे
सर हो
गर्ल्स
गया जी
फर्स्ट पार्ट हो गया ना. तो अभी सेकंड पार्ट करेंगे. देखो सेकंड पार्ट सेम थिंग. यहाँ पे सिर्फ आई एम चेंजिंग. सेम थिंग यू हैव टू डू. सेम ओनली द दिस रेंज इज चेंजिंग. कितना आसान अली बोल दिया. वेरी गुड माशाल्लाह अली. सो ईएमएफ इज इक्वल्स देखो बेटा माइनस ए का वैल्यू डाल दिया. b2 माइनस b1. सो दिस पॉइंट इज b2. दिस पॉइंट इज b1. तो दोनों भी देखो सेम दिख रहा है. मैग्नेटिक फील्ड क्या दिख रहा है. सेम है. तो 1 माइनस दिस इज आल्सो 1. दिस इज आल्सो 1. देयरफॉर 1 माइनस 1. कंग्रेचुलेशन फॉर दैट फेलो. देन देखो टाइम देखो ये ग्राफ का सीधा नीचे देखो टाइम तो यहाँ पे है ना. तो 4 माइनस 2 फाइनल टाइम इज दिस. इनिशियल टाइम इज दिस. तो 4 माइनस 2. कितना आसान बन गया देखो बेटा. EMF is equals to then the next step. So please note down second Roman. So EMF is equals to minus 4.5 into 10 power minus 2 into 1 minus 1 is 0. 4 minus 2 is 2. So what is the EMF? Oh, alhamdulillah. What is the
zero
EMF? Therefore, what is the current? What is we have to find out the induced current, na? So what is the current? EMF is 0. So what is the current? Current is also
zero
E by R na 0. Very good. So second part is over. कितना आसान है देखो. So first in the beginning only you found very difficult. Then it is going on. You see that how it is easy. कितना आसान बन गया देखो. Second part is over. Now third part of the graph we'll do. First you copy. हो गया. गया.
जी सर हो गया.
Third part of the graph. Third part of the graph. This part. Third part of the graph. So you should know the substitution. You should never commit mistake. That's why I'm teaching you this numerical. Here many children they do the mistake. Third part of the graph में देखो EMF is equal to minus area 4.5 10 power minus 2 B2 minus B1. तो final magnetic field minus initial magnetic field. तो यहाँ से यहाँ travel हो रहा है. तो final point कौन सा होता है भाई. ये होता है final point. ये होता है initial point. तो final point on the magnetic field. Magnetic field यहाँ पे है. Y axis पे है. X axis में नहीं देखना है. Y axis पे देखना है. तो यहाँ पे नीचे गिर गया ना. So here it is lying. So here what is the magnetic field? 0 दिख रहा है. Magnetic field in this point is 0. So you have to put 0, final point, minus initial point. Initial point, this point is 0 minus 1 Tesla. Divided by time, therefore 6 minus 4. Very good, very good. 6 minus 4. So this is what I want to teach you, the substitution from the graph. कैसा substitute करते हैं? Always remember that final minus initial. Final minus initial. If you remember this general final minus initial, then you will not commit any mistake. तो बहुत आसान होता है बच्चों. EMF is equals to minus 4.5 into 10 power minus 2 into 0 minus 1 is minus 1 divided by 6 minus 4 is 2 होता है. So minus half. तो इसका EMF का आंसर मिलेगा आपको plus 2.25 plus 2.25 because half only ना into 10 power minus 2. उसके बाद I equal to E by R 2.25 into 10 power minus 2. R क्या दिया था 8.4 8.5. Hello, what is R?
8.5.
8.5. तो I का वैल्यू मैंने दे देता हूँ. I का वैल्यू आपको मिलेगा 2.7 मिली एम्पियर. खलास. देखो कितना आसान हो गया था. So since you don't know, when you see the graph, non-max students, when you see the graph or numerical like this type, it is very simple only. You know the formula. What is the formula? Flux का formula आपको मालूम है. Phi equal to BA का step आपको मालूम है. EMF का formula आपको मालूम है. d phi by dt आपको मालूम है. Then you have to substitute induced current I equal to E by R. Everything you know. But by seeing the graphical question in the numerical paper, question paper में आप देखने मान, then you develop some sort of shivering. You leave that. ऐसा नहीं करना है बच्चों. तो देखो कितना आसान है. डायरेक्ट फार्मूला सब्स्टिट्यूशन डायरेक्टली वी आर सब्स्टिट्यूटिंग फ्रॉम दैट. आई होप यू अंडरस्टैंड. हो गया? हेलो हेलो हेलो, हो गया बच्चों? हेलो हेलो, हो गया?
Yes, sir.
Straight up the board.
Yes.
All other children. Okay. Darwin Timothy, straight up the board. Darwin Timothy Nishta, straight up the board. Nishika. Nishika, are you getting my voice? Hello. Hello, hello. Nishta, Ridham, are you getting my voice?
Yes, sir.
Fire up the board. हो गया? Now there is a board question. Very simple question only. You should guess the formula. Formula अगर से guess कर दिए, you are beautiful, you are wonderful. So just I'll give you the numerical. With that we complete the class today. So just you guess the formula. Okay? Formula guess करके आपको कर सकते हैं. उतना आसान का numerical है बच्चों. Just 2 mark numerical only. Very simple numerical. An aircraft with a wingspan of 40 meter. An aircraft. Note down. CBSE question. An aircraft with a wing span of 40 meter. 40 meter flies with a speed of 1080 kilometer per hour. 1080 kilometer per hour. Just 2 mark numerical, very simple numerical, direct numerical. In the eastward direction at a constant altitude, also नहीं चाहिए. Kilometer. The vertical component of magnetic field is vertical component of magnetic field is given 1.75 into 10 to the power minus 5 Tesla. 1.75 10 to the power minus. Find the EMF. Find EMF. So first thing, listen very carefully, bachcho. An aircraft with a wingspan of 40 meter flies with a speed of 1080 km per hour. Bachcho. Vertical component of magnetic field is given 1.75 10 to the power minus 5 Tesla. Find the EMF. Can anyone tell me the formula by seeing this? Data देखते ही बोल सकते हैं ना? First you tell me the data. Data बोले तो you are brilliant. Data बोलिए. What are the data is given? Wingspan. Aircraft होता ना बच्चों, aircraft. अरे भाई, everybody you are flying ना. All are Saudis children. तो aircraft का wing का length दिया है ना. Wing का length दिया है. So L is given. Can I write L equal to 40 meter? बोलिए ना भाई. Hello.
L equal to 40 meter.
L equal to 40 meter. Very good. Then what is the data is given?
BV equal to
Very good. BV, magnetic field, vertical magnetic field is given. Magnetic field, vertical component of magnetic field is given 1.75 into 10 power minus 5 Tesla. Very good. Very good. Next one.
B is equal to
Huh?
102. B is equal to 1080.
1080. Very good. Kilometer per hour. बच्चों यहाँ पे किलोमीटर पर आवर दिया है. So what we will do in kilometer per hour is given means what we have to do?
सेकंड में चेंज करेंगे.
किसमें चेंज करना है?
मीटर पर सेकंड में.
मीटर पर सेकंड चेंज करने के लिए क्या बोला था मैंने?
1000 से मल्टीप्लाई.
हाँ, वो तो ओल्ड स्टोरी. 1000 by 3000 वो तो ओल्ड स्टोरी. मैंने एक शॉर्ट ट्रिक बोला था ना, क्या है वो? 5 by
18.
5 by 18 से
5 by
5 by 18.
very good.
Five.
Very good. Very good. Very good. So that you should do. Now can you tell me the formula? EMF का find the EMF. What is the formula? So what is the formula? What is the formula by using this thing? Huh?
BLV.
BLV.
Very good. Very good, children. Mashallah. Mashallah. So convert this first. V equal to 1080 into 5 by 18. तो इसका कन्वर्ट करें तो आपको आंसर मिलेगा. मीटर पर सेकंड कन्वर्ट करने के लिए क्या मिलेगा भाई? क्या मिलेगा भाई? बोलो ना भाई.
300 meters per second.
वेरी गुड. 300 मीटर पर सेकंड मिल गया. तो 300 मीटर पर. तो बच्चों ये सब याद रखना है. ये सब टेक्निक होता है, ट्रिक होता है. तो 1080 देखो यहाँ पे, देखो बॉक्स डाल के मैं बता रहा हूँ मैंने. तो किलोमीटर पर आवर. Why we should convert MS meter per second? Can anyone tell me why? What is the reason we have to convert? जल्दी बोलिए. 11th standard what we taught you? Why we have to write in MS per minus? Yes, we have to give the answer always in MKS system. Always we should give answers in MKS system. तो इसको बोलते हैं हमें MKS system बोलते हैं. So we have to convert. Okay. तो conversion हो गया. अभी फार्मूला तो आप बोल दिए. So therefore EMF is equals to BLV. So see how easy the numerical. B कितना है बच्चों? 1.75 into 10 to the power minus 5 into length is 40 meter. तो मीटर में ही दिया है ना 40 into 300. तो इसका बच्चों करें तो आपको कैसा कर. I told you also how to do this numerical, this kind of numerical. Again I am teaching you. Please listen here. Very simple numerical कैसा कर सकते हैं बच्चों. कैलकुलेशन कैसा करना है एग्जाम पे. एग्जाम पे कैसा कैलकुलेशन करना है. Several times, many times I taught you. Many times I taught you how to do that numerical in the exam. कैलकुलेशन कैसा करना है बोल के वो भी मैंने टीच किया हूँ. तो यहाँ पे भी देखो EMF is equals to 1.75 into 10 to the power minus 5 into 4. 4 को सेपरेट कर लो और 3 को सेपरेट से निकलो. कितना जीरो से देखो 1 2 3 जीरो से. तो 3 जीरो को ऐड कर लीजिए 10 to the power 3. This is the way you have to do. You have to learn. Okay बच्चों. So then maximum you can solve here itself. So EMF is equal to 1.75 into 4 into 3 into यहाँ पे क्या है भाई 10 to the power. और इसको भी सॉल्व कर सकते हैं ना. 1.75 को कैसा लिख सकते हैं? Can anyone tell me? Can anyone tell me? 1.75 को कैसा लिख सकते हैं? जल्दी बोलिए. 175 into
10 to the power.
10 to the power 10 to the power minus 1 minus 2 minus 2 minus 2. So 10 to the power minus 5 into 4 into 3 into 10 to the power 3. So this is the way you should do the numerical. तो ऐसा करके आपको प्रैक्टिस होना चाहिए, तो आप कुछ भी न्यूमेरिकल दे सकते हो. So you, even if you are a non-max student, you can do very beautifully with the powers. Powers में लाने का सीख लिया तो बच्चों very simple, nothing to worry. देखो बच्चों, now even the LKG fellow will do 175 normal multiplication. 175 आ गया, 4 आ गया, 3 आ गया. तो देखो ये तीनों है ना, you can do normal multiplication. Even the LKG of Jubail will do, है ना. तो ये हो गया. तो इंटू देखो बच्चों, ये पावर पूरा करना कर लो. So -2, -5, -7, -7 plus 3 गया, so 10 to the power -4. Now you have to multiply this. So the net answer I give you, what's the answer in the book? You please check it afterwards. It is given as 0.21 volt. 0.21 volt. So this is the answer. So this steps also always from 11th standard I am teaching you बच्चों, numerical में जब भी है ना, अपने numerical कुछ भी numerical करो, you have to bring it in a systemized way. So that is powers में लाने कोशिश करो, then you can do very easily without the calculator. Hope you understand. Okay, inshallah we'll see next class. So thanks for participating. Take care. And tomorrow possibly we'll finish this topic, and then from next week we are going to start a new topic called alternating current. Please never miss chapter 7 alternating current, which is highly difficult. Only differential integration आता है बच्चों. तो इसलिए if you miss a single class also you find very difficult. Okay, so take care. Allah Hafiz. Bye. See you. Bye.
Thank you, sir. Assalamualaikum.
Thank you, sir. Assalamu alaikum.
Walaikum
Thank you, sir.
assalam. Okay, beta.